Hey everyone, thanks for joining. We're about to get started in a few minutes. We're just going to let some people join up. All right, if you're just joining us, it's 11 o'clock. That doesn't mean we're starting on time. We're going to give it one more minute because we would like to get as many people as possible to catch the very beginning of the presentation. So we'll give it 1 or 2 more minutes and then we'll begin. All right, I see some more people joining. We're going to give it about 30 more seconds and then we'll start. Thanks for joining. All right, let's get started. Thanks for joining, everyone. My name is Josh Valentine. I'm the Communications Director with the Southwest Energy Efficiency Project, also known as SWEEP, or more commonly known as SWEEP. And thanks very much for taking time out of your day to join this webinar, The Benefits of Heat Pumps for the Southwest, which is being produced in conjunction with our new report that was just released today, Benefits of Heat Pumps for Southwest Homes. So you can check that out on our website. You can sign up for our emails on our website, which is how we sent it today, including the press release. And please follow us on Twitter at Southwest EE. We've been tweeting about it this morning. So please check out that study after the webinar. Give it a good read. This webinar is being recorded, so we will be sending out a link to the recording in a day or two that will be uploaded to our YouTube channel. We will also be sending out the complete slide deck with all of the slides for all 3 speakers. And in the future, the very near future, we're hoping to, well, we're planning on putting on some more webinars about heat pumps in the Southwest, specifically covering states and cities that the study covers. So look out for those. If you sign up for our emails or follow us on Twitter, you'll be updated on that information and when and what time. We will have a Q&A at the end of the webinar. We will try to get to your questions, so you can enter your questions into the question box in your Zoom control panel, and we'll do our very best to get to some of those. Our speakers today, Neil Colway with SWEEP. We have David Petroy with NTS Energy. He wrote the study with Neil. And then we have Robert Foley with ICAST. So we've got a lot to get to right now, so I'm going to pass it off to Neil. Thanks very much for joining.
Thank you, Josh. Good morning, everyone. I'm Neil Colway with SWEEP. I've been with SWEEP for about 12 years, and I'm our building electrification specialist. And joining me today is Dave Petroy, who is an independent consultant with NTS Energy. Dave formerly had his own HVAC company focused on installing ground source heat pumps, and more recently was the sustainability manager at Golden Aluminum, an industrial facility in Fort Lupton, Colorado. Dave has been working with SWEEP and with the Beneficial Electrification League of Colorado for the past 2 years or so, sharing his technical expertise. Just a few hints about the Zoom. Use the chat to make comments and use the Q&A to ask questions. And I'm going to introduce Rob a little later, Rob from ICAST. So today what we're going to do is first talk a little bit about the benefits of heat pumps in general, and then a little background, state and utility support. I'm going to turn it over to Dave, and he's going to talk about heat pump technology improvements and some of the results of the report that was released today that Josh mentioned. And then we'll kick it back to me. I'm going to talk a little bit about all electric new homes and our recommendations in the report. And then I'll introduce Rob, and he will talk about multifamily. So in general, heat pumps are very efficient and they have the potential to reduce heating costs. And in the study, we found that they do reduce heating costs in most of the areas of our region. They significantly reduce carbon emissions. They offer a hedge against volatile and increasing gas prices. And especially if you eliminate gas cooking and have an all-electric home, you can have improved safety and indoor air quality in the home and improved reliability. So a little background for support for heat pumps in the region. First of all, there are state and utility clean energy goals. Most of the major utilities in our states shown here have goals to reduce their greenhouse gas emissions by 50 to 80% by 2030 or 2035. And these goals provide the foundation for achieving the significant greenhouse gas emission reductions through adding heat pumps. And these goals are incorporated into the projected 15-year marginal electricity emission factors for these states from NREL that we used in our modeling and in the report. And you can find more information about the emission factors in the report. Here's a quick look at the utility rebates in the region. There's a lot of information here, but the main point is, again, most of the major utilities have some level of rebates for heat pumps and heat pump water heaters. And this is a start, and it shows there's a growing level of support out there for heat pump adoption. And we will talk about our recommendations later, but basically to overcome the incremental cost, we'd like to see around $1,000 per heat pump in the warmer cities for like a 3-ton heat pump, and about $1,800 in the colder cities. And most of these are a little below that, except Rocky Mountain Powers is in the right ballpark. So more about that later. Training for heat pump installers is very important. And so here's one example of that in our region that I wanted to mention. If the heat pump installer or HVAC contractor is not comfortable with heat pumps, then generally they either try to talk the customer out of them or they overprice them. And so it's important to offer training to overcome that. So in Colorado, we have a coalition called the Beneficial Electrification League of Colorado, or BELCO. And there's a subgroup that is focusing on heat pump contractor training. And there's been a great collaboration between several of the main utilities in Colorado: Xcel Energy, Tri-State Generation, Platte River Power Authority, and Holy Cross Energy. And all the qualified installers or contractors who have attended one of the utilities trainings are listed on our website, loveelectric.org. This website was developed by Belco and paid for through Belco. And that's a really good resource for people to be able to find somebody who knows what they're doing. And we've also been doing quarterly meetings with the largest heat pump distributors and manufacturers. So this is a model that could be replicated in other states besides Colorado. And now I will turn it over to Dave.
Thank you, Neil. Welcome, everyone. So I'm going to talk a little bit about, do a little history on a slide, a little bit more about some of the heat pumps and what they can do before I get into the results of the report. So Neil, if you could go to the next slide, please. So basically, the report focused on ducted systems, but realized, and this is sort of the two examples here on the left side. This is what's called an all heat pump, or people would call it all electric, where you've got the heat pump on the outside. Outside looks just like an air conditioner, and inside you've got called an air handler, an indoor unit that looks like a furnace but has no gas. It might have a little electrical backup in there. And the right side is what's called a hybrid or a dual fuel system. Same thing on the outside with the heat pump. Inside, you've still got your gas furnace, but you're using it mostly as a air handler for most of the year, with the heat pump providing the heat, the gas a bit in the warmer months. And we'll talk a little more detail about that in some other slides. Next slide, please. Before I do that, I want to, another big thing with heat pumps is the multi-zone mini splitter ductless heat pumps. I just want to take a minute or two, since we have a big audience, and just make sure everyone understands the tremendous advantages of this. And I know Rob's going to talk about them also a little bit later. But basically, you have an outdoor unit, and originally they were these 4 wall units that could hang on the indoors and do one individual room each. But in the next slide, Neil, this is the evolution, and it's really been an amazing technology. You'll notice there's units that really quite nice units can go low on the floor. The wall units showing kind of an old style, but if you look on the sites, there's mirrored units that look like mirrors, very decorative units. But I want to point out to everyone some of the newer things. And when I mean newer, in the last few years, there's basically the ceiling cassette, which is flush. A lot of people like that. And then on the lower right is what's called a slim duct. And this doesn't seem that interesting, but it is a big jump in the sense that this unit is small, can go in the attic, can go above closets, but it can do 2 rooms. So with a tiny little system, you can actually do 2 rooms, heating and cooling. And on the far right, they've actually made it, some of the manufacturers made it so you can even combine a normal air handler with these. So that could do 3 rooms. So you've got, especially in the world of existing homes, you've got all these ways to retrofit the home and improve it. Next slide, please. And so here's just a few things, that you can do with them. Swamp cooler no longer effective. What that means, we've heard from folks as things get super hot, over 100, et cetera. Some homeowners might feel they need a little bit more. So obviously this is a solution. There's certain regions where traditionally there hasn't been cooling. A lot of Colorado in the high country, but now obviously folks want more of that. Another thing to keep in mind with this technology is you've got new additions over the garage or extensions, and sometimes it makes a lot more sense to do this than expand an old inefficient systems. And finally, those with electric baseboard and propane boiler heated homes, these can provide a tremendous cost reduction, and they're very flexible to be able to do that. Next slide, please. So this is my little history lesson. I used to talk about the history of heating and cooling from back in fire, but I've cut that out for you all today. What I'm calling a rise of the cold climate heat pump. So really, around the early part of this century, calling the birth of the cold climate heat pumps in North America, there was work in Europe and Japan there, were doing a little bit before us. But really what it is everyone, the engineers and scientists said there's no reason that heat pumps can't work in cold climates. There's nothing fundamental it can't do. So they had all these components that they could play with inside. They can improve the compressor, the fans, the coils, the computer boards. All these components, each of them, if you improve each of them a few percent, a big improvement I'll show in the next slide. So we had field trials in early 2005 to 2010, make sure that they did what people thought they could do. And now, they've been installed in cold climates, New England, Midwest, and Canada. And, in Colorado, it's moving forward quite quickly, and Utah. So pretty much every state, as people become aware of these technologies, that's why we're at this really nice place. Next slide, please. So what did it actually do? There's like 4 big things for these cold climate heat pumps, and heat pumps in general on the first one. Efficiency improvements of 20 to 30%. So that's directly related to, basically think of it as the cost to operate, dropping 20 to 30%. They worked on improving defrost capabilities. You're going to put them in situations where it's really cold and needs lots of defrosting. They put a lot of technologies into that. The thing that really makes it cold climate is the ability to heat the whole house when it's below 30 degrees. In the past, they didn't really need to think about that, basically, because they were just put in warm climates. And now the capacity, when it gets cold, for this heat pump to carry the heating load of the house, obviously essential. And the final thing is the ability to provide heating when it's cold below 0. So many of these heat pumps can go down -5, -10, -13. In a lot of cases, there might be a little bit of electrical to help them out to get through the extreme cold, but these are 4 massive improvements, and that's why we're where we are today. Next slide, please. The other thing is energy prices, and the point is not to, nobody knows what's going to happen with energy prices, and I'm neither Neil nor I or anyone pretends to know, but this is kind of an easy way to quickly see how heat pump operating costs compared to the gas furnace world. And you can you look at the ratio of the pricing, and if you want to know how to do this, people could send an email to Neil or I. It's quite simple, and the magic number is around 3.8, and basically at about a ratio of 3.8, there's sort of on cost par. So think think Albuquerque, think in here, around in here is on par. Less than that is the heat pump is much more cost effective to heat, and above it is slightly more. So notice in a warm weather cities right now, the heat pumps are notably less to operate, and even in the cold weather cities, most of them. And I'll show some specific examples from the report. Next slide, please. Now, people hear a lot about different kinds of heat pumps. It can actually get very confusing, but we've tried to simplify it here in this diagram. On the left side is called heating season performance factor. The higher the number, the better. On the low is called SEER, and I think most people are familiar with that with air conditioning. The higher the number, the better. We're not even going to talk about low efficiency, less than 16. I mean, there's still some out in the market, but at this point, the technology, it's obsolete, quite frankly. Well, let's talk about 2 categories. These are high efficiency 1 and 2 stage, 16 to 18 and 9 to 9.9. There's quite a few of them in there, and we'll talk about when it would make sense to go with those. And then there's cold climate heat pumps, which variable speed refers to the compressor. 1 and 2 stage refers to the compressor. And when you go on websites, you'll see that. And obviously, these are the highest end equipped. Next slide, please. So the scope of the study, we looked at single family homes with ducted. We compared it to sort of the conventional gas heating strategies. And remember, and we looked at warm weather cities. We'll talk about warm weather cities first, and we'll show some results from the cold cities. Remember that a lot of these benefits apply to that mini split scenario too, with regards to retrofitting old homes. Next slide, please. So the warm weather cities, you've seen them here. And what the reason I showed this map is it's climate zones 2, 3, and the yellow is 4. So we're talking about these regions. And though we're focused on cities, the energy savings and the applications of heat pumps apply to anywhere in these regions. It just might be that the pricing of fuels would be a bit different. So really, what we're talking about here doesn't just apply to the cities. Next slide, please. So how did we get to our results? Well, there's an accepted manual, it's called Manual J8. It's a modeling methodology that basically all that contractors should be using. And that's the way they come up with, well, how big of a system do I need for my house? How much heating and cooling does it need, et cetera. So we've built typical homes, 20 to 2,500 square feet, existing homes and new homes. And we looked at the average energy use in the area and we calibrate them. And then we put in utility energy rates from the last fall as we were going into the winter. And from that, we get out how much energy the house will use, what it'll cost, et cetera. Next slide, please. So with existing homes, really the best strategy, and honestly, it's hard to envision why there would be another strategy, is really just AC and furnace. You replace them with the high efficiency heat pumps. And so let's look at some results from that. So this is this would be for existing homes. And there's nothing really surprising here. These are some of the results for the homes. And this would be like the annual heating costs. And this would be the annual cooling costs heating costs with the heat pump. The left column is furnace. And the right side is typically, an incremental cost of the heat pump. The heat pump, think of it, as everyone knows, it's basically a reversible air conditioner. So there's a little bit more in there. That's a little bit more of the cost. Next slide, please. So Neil talked about the rebates a little bit. Here we have just the 5 areas, the utilities. We've got what the incremental cost is, be it a new home. New home would be a little less, 1,000. Existing home about 1,500. You see the rebates. The right column I have there is sort of the rebate for a typical 3-ton unit. And you can see it's a bit less on the average than what the incremental cost is. And Neil will talk about that at the end with some recommendations. Next slide, please. Now, one of the things the industry has to undergo a transformation, and you'll hear all sorts of views as to how difficult that transformation is. In this case, it's relatively easy. Basically, the difference between putting in an air conditioning, a furnace, and an all heat pump, it's just, do you have a gas line and a vent, or no gas and a little more extra electrical? The big thing in the bottom really is controls. And with these, high efficiency units, they're pretty standard. The AC is 1 or 2 stage. Heat pump is pretty much the same, 1 or 2 stage controls. Now, if you do choose to go up and you can obviously go and get a variable speed and get a higher efficiency one and gain efficiency if you have the resources and the means. Those controls are a little more sophisticated, a little more complicated for contractors. And that's why, and sometimes they show a little bit of reluctance to that. But basically, this is not a big deal. This is not a big change. Next slide, please. So in the warm weather cities, it's a pretty straightforward story. It makes sense to go with the heat pumps. I want to mention a little bit here. There's a range of SEERs for sort of these high efficiency ones. In the cold climates, it would make sense for us to recommend get higher SEER ones over sort of the 16s. And if your budget is permitting, people can upgrade to the variable speed heat pump systems. And the benefits, Neil went through some of them. You can read them. I'll just touch on them. Obviously, the cost of operation, and talking about everything from local in your house being a little cleaner, your neighborhood, all the way up to the sort of the global GHG look. And installation is really easy. So that's kind of the simple story of the warm weather. Let's talk about the cold weather. And for this paper, we did do the Southwest, zone 5, which is the pretty green. I've just included Denver from the prior paper just for anyone who's on in Colorado, so to just keep you interested in what we're talking about. So let's go to the next slide again. This one I think surprises a lot of people. Because you think that so let me show you what we got here. On the left side is the percent of annual heating. And so the higher, the more. And on the lower axis is minus 10 degrees F, all the way up to 70 degrees. And I think most people, your gut says, wow, most of my heating, energy, and costs is in when it's really cold. But in our climates in the West, that's really not true at all. And you'll see the 85% is the total percentage of heating above 25 degrees. And so this is a beautiful, heat pumps are unbelievably effective there. And we've talked about cold climates, they can even go below. But I think this really puts things in perspective, that fall and spring are really when a lot of the energy is used to heat the house, maybe into early November and late March. But, thinking that December and January is where the bulk of the heating is, it's really not. Next slide, please. So we're looking at the cold climate cities. Now we have some nice flexible options. I mean, existing homes, you can replace the AC and furnace, or just AC with heat pump furnace, what's called a dual fuel combination. That, given that there's already distribution infrastructure in the home, all the ducts and how they were designed, the strategy for like a high temperature heating, et cetera, and the electrical. So this is really cost-effective strategy to use. The other one is if folks, if you desire, clearly you can replace the AC furnace and go straight up with a cold climate heat pump scenario, realizing that, you have to spend some money and redo some of the old distribution system, et cetera, to make it effective. And then then there's that. And then we touch on that. We'll show some comparisons in the new home construction and the cold climate heat pump systems. Obviously, strategy and features we want to avoid, furnace AC combos in the new home world. So next slide, please. So to give you a little more insight into this, this dual fuel, if I have an existing home, what happens if I change out? One hand, you just got a AC that's going to only cool for 3.5 months. Now you've got this heat pump. It's going to do 3.5 months plus spring and the fall. And the nice thing, line two, that you can think about is now I've got a little bit of hedge against gas prices, because I can kind of set that heat pump and have it do a little more heating, a little less heating, depending on the situation. But in the end, you're really using the heat pump for the majority of your heating, and then you're doing the balance of gas. And the SEER, typically, we're talking about similar SEER levels. We're in cold climates, so cooling is not as big a cost, but it is, obviously critical. And then the next slide here. This is for existing homes. On the left column is the cost with the sort of a gas scenario. On the right middle column is go back. No, I'm going too fast for me. In the middle column is with the dual fuel scenario. And as mentioned in those ratios, you can see it's pretty close. The first couple are within $10, $20. It gets a little bit more, but realize we can really look at these numbers and go, wow, one's better than the other, but these are within $5, $10 a month. So looking at the grand scheme, we're pretty much looking at kind of on par systems right now. The incremental cost is a little bit more than the warm climates, because you've got to do a little more outside protective systems, et cetera. Next slide, please. New homes, the story is similar on the cost. We've got a comparison with the furnace on the left column. The middle column would be the cold climate heat pump scenario. And notice overall, it's just the ratio is the same. It's just dampened down. Now the incremental cost is a bit more. And this looks like a hard number, but we've realized that over the states and the cities, and there's a lot of variation. We're trying to get what's a sort of reasonable ballpark figure. Now over in the right column is the net present value, and with the increased cost of cold climate, it's still a little bit negative or lower for the not as favorable for the heat pumps, but we'll talk about that in the next slide, and you'll address that at the end. Next slide. So what this scenario is here is, this is the rebates currently. This is the column incremental cost of the high efficiency would be, let's call it dual fuel, bit more. Those are the rebates of a typical 4-ton. So you can see, again, it's about, 1/3 roughly. And then you've got the range. We put a little more range on the cold climates and the typical cold climate current rebate scenario now. So you can get a flavor of how things are matching up. Next slide, please. So the installation differences, talked a little bit. The left column is sort of AC furnace. The middle one is the dual fuel. Very little difference, quite frankly. I mean, a snow stand and a cover. And the controls are pretty much the same. So not talking a huge difference. The cold climate, I mean, you've got no gas, you've got the extra AC, but it's really the controls. They're much more advanced. The vendors, the suppliers, everyone's got to have a much higher knowledge level. And so that's really one of the things as a whole society we need to overcome, is just think of those as not being that tricky to install. Next slide, please. And that, I'll go back. That gets to where Neil's slide about training and education we're finding in Colorado. Super helpful. And so, we're looking at existing homes and new homes in the cold climates, new construction, the best, right option, can all electric heating and cooling. We don't want the AC furnaces. Existing homes, you've got the dual fuel option, and, you've got the option to also go upgrade to a all electric heat pump if you want to redo your distribution electrical system. The benefits, basically the same benefits. You can read them, but basically the same benefits as with the warm weather cities. So benefits across the spectrum. And the final thing is the GHG emissions. Neil mentioned it, looking at over a 15-year period, the whole lifespan of this. So this is critical over the next 15 years, and it's 55 to 65% based on the current what other current projections for the various utilities and how fast they're going to change the grid green. And we use the sort of the NREL data, the latest data on that model. So this gives you the bigger picture benefits. Next slide, please. And with that, I'm going to hand it back to Neil.
Okay, thanks, Dave.
Hey, Neil.
Yeah,
I'm going to jump in for 2 seconds. Everybody, if you'd like to ask a question, please put it in the Q&A box. We've got some good ones coming in, so keep them coming, and we'll try to get to some of those at the end. Thanks.
Thank you.
Go ahead. Sure.
Just a few more slides in our part here. I'm going to talk about heat pump water heaters and electric cooking briefly, and then all electric homes, and then wrap it up with our key findings and recommendations. Heat pump water heaters offer a lot of benefits. They reduce cost, they reduce emissions, but there can be some challenges, especially in existing homes. And after the furnace or the boiler, the water heater uses the most energy in the home, so they're important. So first of all, you need enough space. You need around 750 cubic feet, and you need a suitable location. And basically, you don't want to put it somewhere where it's going to blow the cool exhaust from the heat pump onto people who are watching TV or whatever. So you want to put it in a hallway or a basement or something like that. You might have to upgrade the electrical panel, so that can add some cost. If you're just swapping out a traditional electric resistance water heater, then that's not going to be an issue, but you can run into that issue if you're replacing a gas water heater with a heat pump water heater. You need a drain for the condensate, which isn't too difficult. And the temperature needs to be greater than 40 degrees F, so you can't put it in a garage or in one of the colder climate cities. And these are not a problem for a new home, because a builder can easily overcome any of these, but for an existing home, there can be some challenges. So here's a cost comparison, and you can see the second and the third columns there comparing the annual costs for the water heater. And you can see in all the cities shown here the costs for the heat pump water heater are less. And in the case of Phoenix, it's like half as much. Unfortunately, they do cost a bit more to install. Like we're estimating around $900. And so we need some kind of utility rebate to help overcome that. And the last column just shows the total incremental life cycle costs, which are generally around 400, means it costs 400 more over the 12-year life. And except for Phoenix, which is you actually save $140 over the 12-year life. And they reduce greenhouse gas emissions 65 to 69% for that's just for all the different cities we looked at. Guys, they're a bit more efficient than heat pumps for space heating. So let's talk briefly about electric cooking. Gas cooking emits several types of pollutants, including nitrogen oxides, formaldehyde, and carbon monoxide, potentially, which can contribute to poor indoor air quality and potential health issues. Electric cooking eliminates all of those. Gas stoves also leak methane and causes their overall carbon emissions to be significant. So induction cooktops are great. This picture is showing that they're very easy to clean and they're safe. The surface doesn't get hot. They only heat up the pots and pans, and they work amazingly well. And you can see some videos showing how well they work at our website, loveelectric.org/cooking. We did an analysis of, well, what if you put all these technologies together and you eliminate the gas piping to the home completely? So the first line is showing the heating and cooling equipment, hot water, and cooking equipment. And you can see in both of these cities, the all-electric home, the equipment is a bit more. But then in terms of the infrastructure, the gas piping is pretty significant. We're saying around 5,100. And for the all-electric home, it's maybe an additional 1,000. So you add all that together, and in this third row, you can see that for Las Vegas, the all-electric home is a bit cheaper, and for Reno, like $600 more, which is really nothing. And then let's look at the annual heating costs for space and water. For Reno, about exactly the same, but if you eliminate the fixed natural gas charges on the monthly bills and then include that, you can see that even in Reno, we save now about $160 a year on the total heating costs, and we save about half the costs in the case of Las Vegas. And finally, the bottom line is you can see that even for Reno, it's a bit cheaper over the 15-year life of the HVAC equipment in this case. So they're cheaper altogether, and that's surprising to a lot of people. And here's showing another potential benefit. This guy, Mark Attard, who happens to be a green builder, but has a home that survived the fire, the recent fire in Boulder County. And he says having an all-electric home, was very beneficial. He was able to return to his home after only 2 days, whereas some of his neighbors who had gas heating had to wait much longer because it took a lot longer for the gas to be restored. It's a pretty impressive photo showing some of the homes remaining and other areas where the homes were completely destroyed. Now I'm going to summarize here. Our key findings: in the warmer climate cities, heat pumps do reduce the annual heating costs and can be as much as 30%, like in Las Vegas and Phoenix. And the colder climate cities, generally the energy costs stay about the same. And for all the cities, heat pumps reduce the greenhouse gas emissions from the home by 50 to 65%. All electric new homes are cheaper to build and operate, and based on the total life cycle costs I just mentioned. They reduce greenhouse gas emissions significantly and have better health and safety and reliability. So to get all of those lovely benefits, here are some of our recommendations. For utilities, we recommend that they offer rebates for cold climate heat pumps and additional incentives to encourage all electric new homes. For existing homes, we suggest emphasizing replacements of central air conditioning systems with heat pumps and reducing the AC rebates and increasing the heat pump rebates. And here's our suggestions, 2 tiers of heat pump rebates. As Dave discussed, the efficient 1 or 2 stage heat pumps with these specs. We would like to see a rebate of around $1,000 for the warmer climates and $1,800 for the colder climates to overcome some or most of the incremental cost. And for the cold climate heat pumps, we'd like to see a rebate of about $2,500 to help reduce some of that incremental cost. And support and collaborate on heat pump contractor training programs is very important, as I mentioned. For state public utilities commissions, we'd like to see favorable rate structures that support heat pumps, for example, time of use rates. And to avoid the expansion of gas piping infrastructure, we encourage them to push electric utilities to provide higher incentives for all electric new homes. Finally, local governments, we'd like to see expedite permitting and reduce fees for new heat pump systems and all electric new homes, and to update building codes to require all electric preferred, or at least electric ready new homes. And the other thing is just everybody needs to work together to continue to educate consumers about the benefits of heat pumps and to encourage people to stop putting in air conditioning. And now I would like to turn it over to Rob. We will save our questions until after Rob's presentation. Rob Foley has worked in residential construction for almost 40 years. He is a BPI certified energy auditor and a QCI inspector. He has conducted hundreds of energy audits, capital need assessments, and energy efficiency models. His knowledge of construction plus building science allows him a unique perspective for helping multifamily owners develop cost-effective approaches to energy upgrades and their carbon reduction goals. Rob?
I guess I get to unmute. Thanks, Neil. So I'm going to chat about multifamily for a few minutes, because while Neil and David's work is outstanding and helpful in helping people to make good decisions about heat pumps in single family, a lot of the lessons they've learned don't really apply to multifamily. So let's jump into that and I can explain why. So next slide, please. So ICAST is a nonprofit, a 50c3. We're based in Lakewood, Colorado. We do a number of things in the multifamily field in particular. That's where we decided to stake ourselves in trying to help multifamily properties to become more energy efficient, reduce their carbon footprint. And in particular, we focus on low-income multifamily, which we find to be, when it comes to building technologies, we pick the hardest part of residential to work in, because there's not a lot of money in low-income multifamily, and so you got to bring a very strong case to get low-income properties to upgrade their mechanical systems and reduce their carbon footprint. And so our goals as an organization are to try to promote affordability of housing, make housing more sustainable, as well as impact climate change and economic development there. So next slide, please. So how do we do that, or what do we do? Well, we're kind of unique in that we run a number of rebate programs for utilities. For example, in Utah, we run the multifamily rebate program for Rocky Mountain Power. So that's part of what we do. But mainly what we do is we act as a nonprofit general contractor. And in doing that, we do that so that we can facilitate the adoption of energy efficiency technologies in multifamily properties. And so we act as kind of a one-stop shop to help properties to make green upgrades by incorporating those rebates and whatever incentives and grants are available to help move the needle in a market that is very hard to move the needle. And in addition to that, we do things like helping new construction make better design decisions, especially in terms of mechanical, by providing incentives to them, or at least education as to the importance of adopting these technologies we've been talking about, like heat pumps, and in particular, cold climate heat pumps. And we're doing really well. Last year, we touched 28,400 multifamily units. And we averaged about 23% energy savings on those units that we touched. And over the last few years, we've had about 12,000 heat pump installations. So we've learned a lot, we've done a lot, and we're doing more each program year as we work hard to help multifamily properties to become more energy efficient. Next slide, please. So I want to give you 3 quick case studies where we implemented heat pump installations. But I just wanted to mention quickly that when it comes to what David was talking about, these mini splits, the industry, the manufacturers have really created a problem for themselves, because we got too many labels for this equipment, and many of those labels are distracting. Mini splits, ductless, hyperheat, right? The important things are 2 things: that they're heat pumps, and that they're hopefully high performance or cold climate heat pumps. That's what's important. And these other labels a lot of times just add confusion. They're important to contractors, so they understand what they're installing, but to the end user, unfortunately, we sometimes are our own worst enemy in that we're using too many terminology, too many terms, when if we kept it simpler, it'd be a lot easier to communicate the benefits of these technologies to people. So, but next slide, please. Let's talk about these case studies. These are all in Utah, these 3 studies we're going to talk about. This first one, they had resistance electric heating. They were small apartments, and so where the outlets for the furnace were made it difficult for them to locate their furniture. So one of the things that we did there was we put in high wall head mini split type systems. And in this case, we got about $40,000 in rebates from the utility, from Rocky Mountain Power. We got about a 5-year payback on this one in terms of the energy savings for what we did here, which in this case, the property owner was paying the utilities, and so that was a powerful incentive for him. That's an easy sell when you can pay back the improvements in 5 years. That's our bread and butter when we can find those. But a lot of times that's very hard to find for a couple of reasons. The big one being the split incentive, which is that most of the time a property owner isn't paying the utilities. And so his motivation isn't going to be the savings from utility savings. It's going to be something else. And we'll get into that in a second. Let's go to the next study. Next slide, please. Here we had an 8-story high rise that had an existing boiler and chiller that were about 40 years old. It was time to replace them. And here we went away from gas heating. So this is one of our big success stories. We replaced gas boiler with heat pumps, individual multi-head heat pumps in each of these apartments, and 300,000 kilowatt hours saved annually. But even in gas heating, we made this a viable economic proposition for the property owners that allowed them to move away from gas heating. But it took a lot of incentives from the utility, in this case, almost $75,000 in incentives to help move the needle, help get the property owners to move away from gas. Next case study, please. And here are the Kirk apartments. They had electric baseboard heating, and we were able to put in high efficiency, high wall head mini splits in this case, and average annual utility savings of $30,000. So again, when we got resistance electric heating, the economic case is very powerful. But only if we're talking to the person who's paying the utility bills. So what I want to just concentrate my time on now is just talking about the lessons we've learned over the years when it comes to trying to implement these high efficiency technologies in multifamily. The big one is that incentives, rebates, and grants are critical in multifamily. And they're critical for one simple reason. Most of the time, the person who's making the decision about replacing equipment or upgrading equipment is not paying the utilities. So energy savings isn't the way to sell this to property owners. It's all about what's the bottom dollar, right? And so most multifamily property owners, their strategy for replacing mechanical equipment is called replace on fail. If it ain't broke, we don't fix it. And when we do fix it, we fix it with the cheapest thing we can find. And so that makes our job very difficult because we've got to figure out a way to put together a package where the least expensive option they have for replacing their equipment is a high efficiency heat pump. And so incentives have to cover that incremental cost difference between the cheapest option and the high efficiency option. That's critical in multifamily, which is about a third of the housing in the country. So whereas incentives aren't the biggest driver in single family, they are absolutely the biggest driver when it comes to multifamily because of that split incentive. Building owners are just they're not moved by energy savings. Now some, especially in higher end multifamily, are motivated by carbon savings. They might have a sustainability office in their, but it's not dollar savings because they're not getting the dollar savings. The other thing to remember about really with all mechanical equipment, but especially with multifamily, is that we get very limited bites at this apple. In other words, replacement cycles only come around sometime between every 15 and every 30 years, right? And if we want to get everyone using heat pumps by 2050, which is a national goal we've set out, in multifamily, that means we got maybe one, maybe two bites at that apple between now and 2050. So every time that multifamily owners are thinking about replacing equipment, we got to be in the room talking to them about the benefits of heat pumps and heat pump technology. We got to make the most of those limited opportunities. And so we need incentives, and we need them right now in order to make the heat pump adoption in multifamily viable. So the next slide, please. And so dual fuel, like David talked about, is a very powerful help for us in multifamily, partly because it's familiar technology to multifamily owners in the sense that they already got a gas furnace. If they've at least got that as their backup heat, that makes the comfort level greater to move toward heat pumps. And it's all about capital cost for owners. So if we have a dual fuel approach, sometimes that means that we can use a less efficient heat pump that's less expensive, because of course capital cost is the big thing, the big driver with property owners. And so reducing that cost for them by having a dual fuel approach is helpful, especially if their existing furnaces aren't that old, and we can use the existing furnace and just add a heat pump to it as the primary source of heat. And when it comes to scaling, it's not about the cost of energy, it's the capital cost that's the key component, right? And so we are focused on helping to put together strategies and approaches that make that heat pump the least expensive option, especially when we have existing apartments that have central air conditioning, right? That's where we're giving the pitch to our property owners, is when they're replacing their air conditioners. We're saying, instead of replacing your air conditioner with an air conditioner, we think you should replace it with a heat pump. And we have such fabulous incentives available that will actually cost you less than replacing your air conditioner with the cheapest air conditioner that you can buy. That's kind of the value add that we try to bring to property owners, to try to convince them to move toward a technology they would never adopt, because that's just not their business model. That's not their approach, unless somebody educates them. And that's how we try to move the needle when it comes to building owners. Next slide, please. We also have real challenges with contractors, as Neil and David and I discussed, right? Getting contractors on board to heat pump adoption is a critical component. So many contractors installed heat pumps in the 70s and 80s and had bad experiences with them and kind of left that behind, especially in cold climates. And so it takes a lot of work, a lot of education with contractors to help them to understand that the technology has changed and this is the way that we're going, so that they become a partner instead of a roadblock when it comes to heat pump adoption. And so a lot of that involves training. And so we are involved in a lot of assisting contractors to become much more familiar with heat pumps, and in particular cold climate heat pumps, so that we are installing them where we can. So in terms of incentives, rebate programs, we need to keep those programs simple and easy for contractors or for homeowners to use them. So often, in my experience with rebate programs, I've been working in rebate programs for a dozen years, it's not worth the time to fill out the paperwork, because the paperwork is either so cumbersome or the incentives are so small that we got to keep those programs simple. We got to make it, we have to make it easy for the end user to use those fundings to overcome the incremental additional costs of these higher efficiency systems. And then the other thing that we need to do when it comes to rebate programs is we need to get rid of the low-hanging fruit. We have been replacing light bulbs and shower heads for 40 years. It's time to move on and just focus on deep retrofits. That's where we're actually going to reduce emissions. That's what we need to be spending rebate dollars on. And so, and then in terms of policy changes, right? We need to recognize that high efficiency heat pumps is where it's at, and that's what needs to be incentivized. Especially for new construction and for major rehab, we need to give the developers, the builders, the contractors, all the dollars they need to make sure that they're making the right choice toward high efficiency and toward beneficial electrification. Like Neil talked about, time of use rates that reward efficiency, as opposed to like what Black Hills in Colorado does. We need to incentivize the cost of carbon, right? Nobody's doing that yet, right? And if we had those dollars as well, we could have a lot more dollars to throw at rebates and incentives. Our rebate system is based on an old model. It's based on how much energy are we saving the utility, and we need to move away from that, because what's much more important than saving the utility, the cost of building a new power plant, is reducing carbon. That's where the dollars need to be. We need to eliminate rebates for air conditioners. Neil talked about reducing them. We need to get rid of them. We need to incentivize heat pumps, not air conditioners. And finally, we're also, last slide, please. We're also working hard as part of our workforce development to help train, particularly entry-level mechanical contractor apprentices, so that we got a lot more of a educated workforce to install these new technologies. So we're working hard in our little field of multifamily to help move the needle in heat pump adoption, and happy to answer questions about that as well.
Josh, do we have any questions?
We've got some good ones. Thanks, everyone. Thank you, David, Robert, and Neil. And I encourage you to just jump in on these questions. It's okay if you talk over one another. So I'm just gonna lunge them at you. Drew is asking, regarding cost comparisons, how is the social cost of carbon used in the sweep study? What figure did you choose to use? And if you can also explain what it means, social cost of carbon, for those on the webinar who are not familiar.
Okay, yeah, I can take that. Well, what it means is it's a way to try to do what Rob just mentioned, is to give an actual value to the greenhouse gas emission benefits. And so we did some calculations in the study of if you take the greenhouse gas emission benefits and then you multiply that by, in our case, we used the federal cost of carbon, $84 per ton. And there's more to say about that, but we don't have to get too nerdy right now. So if you do that, then you get a value. And we in the report, we talked about, well, that can be a guideline for deciding how much the utility could be. Like you could think about, and in Colorado, the utilities are encouraged or required to do that in their beneficial electrification plans, which that would apply to XL and Black Hills. But throughout the region, it can be a guideline. You can look at the value of the carbon benefits and think about giving a rebate that is at least that much. And it is around the amount that we recommended that I mentioned, 1,000 or 1,800 for the high efficiency heat pumps, 2,500 in the case of the cold climate heat pumps. It's in that ballpark.
Great, thank you. And for anyone who's wondering, we do have this webinar scheduled for until 12:15 Mountain. So we've got some good time for the Q&A. So your timing was impeccable. Gerald is asking, does anyone use tax credits as an incentive in addition to rebates, especially in multifamily units?
Rob, do you want to take that? And I can mention New Mexico has some tax credits in Colorado.
Yeah, as an incentive tool, it's not a great incentive tool in multifamily simply because a lot of those tax credits, they're designed for somebody who has a home and it's a rebate for their home. And so they're just not really designed for an investor who's they got a whole different field of tax credits that they deal with. So that's just not a great tool to incentivize adoption in multifamily.
I'll just mention briefly that there is a tax credit in New Mexico that applies to heat pumps in existing or new homes. And in Colorado, there was a new one just passed this year that you get a 10% tax credit for the cost of the equipment part of the heat pump. So for example, if your heat pump costs $8,000, then you get a $800 tax credit. So that'll help a little bit.
Thank you. Amy is asking, and she has a follow-up question as well. Can someone speak to the relationship between heat pump heating and cooling and time of use rate structures? In what ways do time of use rates support heat pump technology? And then she's asking, wouldn't the electric loads cost more to do during peak hours?
I can start, Rob, and then you can jump in. In the case of the heat pump, generally, the rates are lower in the winter months when you're doing the heating. So in that way, it's beneficial to the heat pump. Generally, the utilities in our region have higher rates during the summer months and lower rates during the winter months. So that helps heat pumps. And in the case of heat pump water heaters, they also have like a peak, the time of use rates have like a peak period, let's say like 3 to 7 p.m. And the heat pump water heater can be programmed to avoid, unless somebody comes home and really needs a shower, but you can program it to basically avoid those hours. And so in that way, the time of use rates can also help.
Yeah, and the other answer is smart controls, smart thermostats and things that know when the cost of energy is going up. And so, for example, if your peak rate hits at 3 o'clock, a smart control is pre-cooling a building so that it's at 65 degrees at 3 o'clock and doesn't run for the next 3 hours because of that, right? So it's smart controls that know when electricity is expensive.
Yeah, to just add, this is going to be evolving and the rates are going to be a lot more sophisticated with all the rollout of time of use meters. Now, actually, utilities can understand how we use energy and can start to look at how individuals might change and as Rob says, smart control. So this is going to be an exciting area in the next several years.
Thanks, guys. And Amy's follow-up question is this. I also hear lots of mention of incremental costs, but I'm not familiar with that term. Can someone elaborate? So if you can just explain what that means.
Dave, do you want to take that, or I could take it?
Sure. So incremental cost is sort of the easiest thing is if you have a, furnace and a air conditioner versus an equivalent furnace and heat pump, what's the difference in cost? Or if it's going to be a furnace and air conditioner versus all heat pump, what's the difference in cost? And there's two things that make this a little confusing to everyone is there's a lot of comparison between apples and oranges. So you really need to compare the same level of equipment. And the other one is right now, the pricing regionally and cities and from contractors fluctuates all over the place. So really the way to do it is if you really want to try to understand what's the real one is, you start to get several quotes from several people, and we try to keep our on the pulse of what the differentials are. So, those are the ways to look at it. And you kind of know from the equipment manufacturers, really, if you think about a heat pump, say those high efficiency ones and the air conditioner, there's really only a couple components that are different. So it's a differential in cost between an apples to apples comparison system.
And the reason we talk about incremental costs so much is because the traditional utility rebate concept was if we can provide a rebate that covers the difference between the cost of the cheap equipment and the efficient equipment, that for the end user, it's the same cost, right? So that was kind of the value proposition. And this is what we need to go away from, because we need to be incentivizing moving to carbon reduction. So that's what we need to be incentivizing now. We need to get away from this old thinking about old energy efficiency programs, because our goals are very different now. We're not just helping people to be efficient, we are reducing carbon, and there's value to that.
Yeah, and that, Neil, you might want to touch on that. I mean, that's where we put in that's where the social cost of carbon, and you kind of try to figure out what's a rebate that takes that into account. I don't know if you want to expand on that, Neil.
I think we did a minute ago. But yeah, so like you said, Dave, it's an attempt to think about what's a rebate that is justified by the carbon benefits and instead of efficiency benefits, which Rob just mentioned. So, but anyway, you do, and as Rob mentioned, you do want to eliminate most of the incremental cost if you can for the heat pump in this case versus the gas equipment, because otherwise, the homeowner may decide not to do that.
Thanks, guys. And fairly related, Kelsey is asking, how do you incentivize a property owner to replace their HVAC equipment prior to failure?
Well, it's a tough sell, right? And the utilities call that early retirement, right? And so they have different incentives if you've got existing working equipment versus equipment that's dead. And so they're higher incentives that help us to get people to throw away or dispose or replace equipment that's working. So that's the short answer. It's called the early retirement.
But there is a trade-off. I mean, certainly there was carbon to make that equipment, so we have to be careful. The trick is to try to get things that are near the end of life. For example, we have a system that's 17 years and older. It's not failed yet, but it's getting end of life. Can we get people to replace it earlier? If you just bought a 5-year-old system, it's probably not worth throwing that away right away. So there's kind of this crossover point.
Dave, here's one for you that looks interesting. Thomas asks, under what conditions is a ground source heat pump better than air source? Building size, weather, etc. So maybe you could give a brief answer to that. What do you think about
Sure.
ground source?
So 10 years ago when I did ground source heat pump, or longer than that, air source heat pumps were not very efficient. They weren't cold climate, et cetera. I'd say air source heat pumps have evolved so much that for most cases, single family, multifamily or stuff, it's really hard to make the case for the extra cost for the ground source. I think the scenario that they really start to make sense is when you scale to large commercial buildings or large municipal buildings with a long, say 60-year life. And you really want to you can put money up front. You really want to try to drive that operational cost down and make it more consistent. So that's currently that's my thinking on it.
Thanks. And Neil, that was the exact question I had teed up.
Huh.
Great minds think alike. All right, so Charles and Teja have similar questions about training programs, and Charles basically prefaces his question saying that there's been some issues that he understands with installers either not being trained enough and installing, not understanding the coolant charging and line set seals, creating some leaky systems. So they want to know if there is an heat pump focused installation training happening anywhere in the Southwest for new contractors.
And we actually have two of them. We have grants from the Department of Energy. It's called the Benefit Grant that we're working with Santa Fe Community College to do just that. And then we also have a grant we're working with the Energy Efficiency Business Coalition in Denver to provide contractor training as well for heat pumps. And so those are the two I know of because we're running them. And so if anybody wants to contact me about those, I'll be happy to point them in the right direction.
Awesome.
There's a few utility sponsored ones in Colorado. XL did one, what was it, about 3 weeks ago or something, and they had like 130 people attending, and I think it was not a full day, but like most of a day, and they covered a lot of these important technical topics. So there's a few things out there. If you want to, get on somebody's mailing list, email me and I can give you some updates.
Thanks, Neil. And if anyone wants to contact Neil, his info is on our website. And Bruce is asking, could you briefly cover again the value of heat pumps in areas where it does get cold, where backup gas or electric strips are needed or not?
Not sure. Okay, Dave, go ahead. I think he's asking, like, do they still make sense if it's a really cold area or something?
So, we talked about up to climate zone 5, and they definitely make sense. I mean, you can look at either way. You can go with the dual fuel, or you can have the electric strip backup. There's difference in the economics. When you start to get it way up in the high country, it is a little more challenging on design, et cetera, because it's very cold and you have the altitude. So you do have to take that into account in your thinking of whether you're going to go with dual fuel or a cold climate heat pump. Just remember, overall, though, the heat pump, no matter where it is, for most of the year, be it 9 months in the climate zone 5 or 8 months in climate zone 6, 7, it's still, very valuable in providing all of these benefits, no matter how you think about it.
Thank you.
That's a good answer.
I say we close it out with more of a comment, and maybe you guys could elaborate on it, or just comment on the comment. It's from Nick, who says the fundamental difference between the two HVAC systems is that a heat pump can heat and cool, while an AC unit cannot do both unless it is paired with a heater. Good stuff. So if you have any comments on that, by all means.
Yeah, that's kind of a lot of what I think all of us agree here that we should stop putting in just air conditioners. We should be replacing them with heat pumps, and It does the cooling, heat pumps do the cooling very well. And you have the added benefit of offsetting some of the, emission producing fossil fuels.
There's really no reason to put any more air conditioners in anymore. You just can't think of really a reason to justify it.
I think these are appropriate final statements. So thank you so much, guys, David, Robert, and Neil.
Thank you.
Great presentations.
I guess, is there a lot of questions? Did you want to compile them, Josh, and we could individually answer them then to folks, or have people email us?
Sure
the ones we
thing.
didn't get to?
I can do that. And if everyone on this webinar wants to take a look at the slide, it's been up for quite a little while now. It's got the contact information. We'll also be emailing everyone a link to the recording of the webinar, including the slide deck. And as I said in the start of the webinar, SWEEP is hoping to schedule some more webinars in the coming months regarding the states and cities specific to the study that we just put out today, benefits of heat pumps for Southwest homes. What will we have sent out a press release. You can access the study on our website, swenergy.org, in the publications section and the building efficiency section. We've also put it on social media. You can follow us on Twitter, Southwest EE. And once again, thanks everybody, our speakers, and thank you so much for attending, and have a great rest of your week.